Hello everyone, my name is Will Dower, and I'm part of the Security Automation Framework team at CMS. This presentation will explore the Security Automation Framework's goals, tools, and resources available for use by CMS teams. Let's start off by discussing how security automation can benefit your team. During the software development lifecycle, even minor changes to a system's configuration or codebase can introduce security vulnerabilities that might not be noticed until they are expensive and time-consuming to fix. Organizations need to keep up with ever-evolving security requirements while still being able to deploy applications at speed. They can do this by implementing security automation techniques, which allow your team to monitor your system's security posture. To that end, the CMS Security Automation Framework, or CMS SAF, was developed by the Information Security and Privacy Group and the security community to streamline security automation for systems and DevOps pipelines. You might recognize some of this content as previously being under the header of CMS's DevSecOps initiative, because that work was expanded into the framework that exists today. It can be used for traditional software development methods, as well as fully featured DevOps pipelines. Any team can get started using CMS SAF. It can be applied to any development or operational workflow. This project is constantly evolving. We are always adding new content sourced from teams at CMS who use and improve on our offerings. By using the CMS SAF, your team can access a set of tools from a common framework to implement security, visualize security status, drill down to identify root causes, and mitigate security risks. Developers can secure their systems by validating their security controls early and often within their environments. They can integrate the framework into their own orchestration, functional, and unit testing systems to keep security defects as low as possible. By implementing security and privacy early on in the software development lifecycle, the CMS SAF can expedite the ATO process. It can help you support continuous assessments and ongoing ATOs. I want to note that the Adaptive Capabilities Testing team will accept security testing data from this framework. The use of CMS SAF is a best practice recommendation from ISPG. I encourage everybody here today to take a look at our website at saf.cms.gov and take a look at the SAF's testing profiles and visualization tools and see how they can be used to save you time and headaches. The CMS SAF website's resources and toolset were developed by CMS ISPG in cooperation with the open source community and software vendors and are available for use free of charge. Now I'd like to give you an overview of what those resources and tools are. The Security Automation Framework is focused on 4 main activities. The CMS SAF allows you to harden your systems to security baselines. You can also validate your security against ARS requirements. You can normalize data from various security tools into a single common format so that you can visualize all of the data for your system and understand where your security problems are throughout the lifecycle of your system. We base our hardening and validation content on standards from government and industry, such as DISA-STIGs and CIS benchmarks, which are then tailored down to meet agency requirements. We can use the output from your favorite commercially available and open source testing tools as an input to our own framework to support normalization. This allows you to aggregate your data for more effective visualization and analysis. We support all of these activities with our Security Automation Toolset, which incorporates orchestration tools like Ansible, Chef, and Terraform for hardening, Chef's Inspec framework for validation, Heimdall Tools for normalization, and the Heimdall visualization application. which I will demonstrate in a moment. CMS has been a proponent of each of these tools. Many of them, including our large library of tailored in-spec testing profiles, the Heimdall application, and various supporting tools, were developed by MITRE on behalf of CMS ISPG. So I've talked about the components of the CMS SAF, but I also want to touch on how and when you can use them. You can leverage the framework at any time throughout the software development lifecycle, from planning and pre-development work, into development, through your assessments, whether those happen annually or if you're working with an auditor, all the way into the operational life of your system. For example, during the planning phase of your project, you can use our best practices guides to structure your work. You can plan out your testing strategy around the tools offered by the SAF. You can use our hardening and validation content during development to test your software every time you change it to ensure that you catch security problems immediately. Because our testing content is aligned to ISPG policy, you can easily use these tools during assessments. Every profile on the SAF site will tell you exactly what ARS security controls it covers, for instance. Visualization is also extremely helpful to getting actionable information out of an assessment. We also want to stress that you can even keep running validation tests once your software is operational. Using Heimdall visualization, you can easily see that you have just as strong a security posture on day 100 as you did on day 1. So now that we've had an overview, I want to take a closer look at some of the content available on the site for your use. I'm going to head to our validation page, where we collect validation profiles developed for use in the CMS community. The CMS SAF has a collection of security validation profiles written in the Chef Inspect testing framework. These are ready to use, free of charge, and aligned to the CMS ARS. Every box you see here is a link to the CMS GitHub repository where the Inspect testing code lives. You can download this at your leisure. Every one of these profiles is based on government and industry standards, such as STIGs and CIS benchmarks, and then tailored down to meet ARS 3.1 standards at a level of low, moderate, or high. The CMS SAF has profiles to cover components all over the application stack, from cloud service providers to operating systems to databases to application logic to web servers. Every one of these profiles was written by a team at CMS and linked here to ensure that teams in the future would not have to reinvent the wheel. Inspect profiles can be run against a target component manually from a laptop, or they could be included into a full CI/CD pipeline to run on every code commit. You can use these in whatever manner fits with your project. Now, if you don't see a system component that you want to test on this page, we encourage you to reach out to us so that we can help you write a validation profile for it. The CMS SAF team offers training around once a quarter on how to develop a testing profile using Inspec. Now, a primary goal of the CMS SAF is to allow you to identify the overall security status of a system and then deep dive to solve specific security defects. To do this, we utilized MITRE's Heimdall application, of which CMS was a primary supporter during development. Heimdall allows you to take the output from running one of these testing profiles and visualize it in a way that is easy to digest. So let's go take a look at Heimdall Lite. Heimdall Lite is a browser-only version of the application, and just like the SAF site, I encourage you to go here at heimdall-lite.mitre.org and take a look around. This site is available as a demonstration that's free to anybody to use. You can load data into Heimdall in a number of ways. You can pick files from your local system, from an S3 bucket, or from Splunk. We also have a few sample files available. But for now, I'm going to pick a file from my local system. The file that I'm going to load represents the results of running an inspect testing profile against an unhardened Red Hat server. All right, you can see that it's loaded. Now, when I load these test results, I can examine metadata about the profile I ran. And then as I scroll down, I can see more data about what the results of the tests were. I can see the passes, I can see the failures, and I can see the compliance level they represent. I can see the severities of each test that was run as part of this profile, from high to medium to low. If I scroll down, I can see a map of what security control families these tests cover. If I scroll down even further, I start to see a view of individual test results and whether they were passes or failures. So this information is good for an overview, but we also want to be able to dive deep into the tests we ran and examine why some of them failed. Let's say I want to determine why my Red Hat server is failing the high severity tests. I want to filter what is displayed on this page to only show me high severity failures. I can do that by clicking on these donuts. If I go to my severity view and select the high severity tests, and then I go to the status view and I pick the failures, I will restrict what is on this page to only the tests that I care about right now. Now, I can examine a test in more detail to get a better understanding of what went wrong. For example, if I take a look at this test, which is checking to see that my Red Hat server is running a virus scan program, I can see exactly what checks were done as part of this test. In this case, the profile was expecting a couple of virus scanning services to be running. They were not, so the test failed. I can go to the Details tab, and I can see metadata about this particular test. The title, the description, a control alignment, a severity, the check text describing exactly what it is trying to check, and the fix text, which will tell me how to solve the problem. If I want to, I could even click on the Code tab to see exactly what code was run on my system. What you're seeing here is the contents of an inspect testing profile. This is the code. So let's say that I've examined a number of these tests, and I've decided that I don't like my 36% compliance level. I want to go back and harden my Red Hat server and try to get this number bumped up. So let's say I go back and I do that hardening, and then I rerun my inspect testing profile, and I get another results file. I can load that file straight into Heimdall alongside the previous run and compare the two. I'm going to pick a file from my system, which represents the output from running an inspect testing profile against a hardened Red Hat server. You can see my two profiles. This view has now aggregated the tests together, but I would rather compare them. I'm going to go to my comparison view. Now I can see a delta between the two test results that I have loaded, one the vanilla and one the hardened Red Hat server. I can see that my compliance level went up. I can see that my failures went down. I can see that my passes went up. And if I scroll down, I can see the delta. I can see the difference between failed tests in the first profile that became pass tests in the second. So what we've done here so far represents a very simple use case, where I am manually loading files into Heimdall after running basic tests against a single system component, in this case the Red Hat server. Teams are encouraged to stand up their own Heimdall server to ingest security data from your developer workstations, administrative management environments, or CI/CD pipelines, based on your preferences for when and how you would like to run the CMS SAF tools via the API built into Heimdall server. But Heimdall is designed to view more than just inspect data. That's why the CMS SAF focuses on normalizing data to convert security tool output from all of your favorite security tools into a common data format called Heimdall data format. Heimdall Tools is a CMS SAF offering which allows you to convert the output from such tools like SonarQube, Fortify, OWASP Zap, and so on into the Heimdall data format. I can then load this test data as easily as any inspect profile. As an example, I'm going to go back to Heimdall Lite. I'm going to load one of our sample profiles. This one will be for an OWASP Zap profile that we converted into Heimdall data format using Heimdall Tools. Now, I don't need to compare this one with the Red Hat profiles. I'm going to go ahead and get rid of them and go back to my results view. As you can see, I can load it as easily as any other profile. I can see metadata on the test. I can see results. I can see severities. And if I scroll down, I can see individual tests, their results, and further details I can deep dive into. I don't like the look of this SQL injection vulnerability. I should really pay attention to that. So now we've discussed ways of performing validation, visualizing the results, and deep diving to solve specific security defects. The CMS SAF also focuses on ways to allow you to remediate these defects. This is our hardening content. The CMS SAF allows you to implement security baselines using Ansible, Chef, and Terraform content. Our partners at MITRE host baseline implementation and hardening content. Over time, CMS will populate this page with overlays to these implementation baselines, which will be tailored to specific CMS policy requirements, just like the validation page. For the moment, you can go to the MITRE security automation site and find hardening baselines, which are aligned to government and industry standards, such as DISA STIGs and CIS benchmarks. So this covers the four main goals of the CMS SAF: harden, validate, normalize, and visualize. The site also includes additional information to help you integrate the SAF into your work and projects. For example, we have an FAQ to cover common questions that we hear from teams who are interested in security automation, such as how are the ARS controls aligned? What are our best practices for code review? What are my options for deploying InSpec in my environment? And so on. As I mentioned previously, We also offer training on how to write and tailor an inspect testing profile. While using existing inspect profiles is great and recommended, tailoring and creating new profiles helps to increase the precision and relevance of security testing for your environment. CMS ISPG has a process for peer review and vetting your tailored profiles. Once you've done so, we can add them to our validation profiles list. Our partners at MITRE offer regular inspect training courses, about once a quarter. So as you can see, the CMS SAF has a lot of content. That's why we developed a Getting Started page to help you start to plan how to integrate our content into your workflow. On this page, you can find some basic questions to ask yourself if you're looking to use CMS SAF. Questions like, what are you creating? What is it that you need to secure? Do your components have hardening and validation scripts available, or are you going to need to build some? What other security tools are you using so that we can run them through Heimdall Tools and visualize them using Heimdall Data Viewer? And so on and so forth. So, to recap, you can use this site to help you harden, validate, normalize, and visualize. We invite you to take a look at our sites and our tools and give us feedback about what you see and what you would like to see on this site. You can reach us at saf@cms.hhs.gov. The Security Automation Framework was built on a great community of security automation practitioners at CMS, its partners, and the open source community. We've had the pleasure of working with a bunch of great teams within CMS, such as the ACT team, which now uses our security testing data for its own assessments. We've worked with the CFACTS team, we've worked with the MacFin team, and half a dozen more. We would love to hear from you, and we would love to have you on this list someday. Thank you very much for your time, and I think we'll move to the Q&A.